long before maps on clocks or written calendars. Ancient people looked up at the night sky and found something powerful order. The stars told them when to plant, when to sail, when to fear an eclipse, and when a king's power might be in danger. But this sky knowledge did not just guide civilizations, it also outlived them. Before we go deeper, take a moment to like the video and subscribe. If this is the kind of history and mystery you enjoy, long before the first city wall rises from mud brick, before any king stamps his name into wet clay, before the first pyramid cuts its shape against the desert sun, there is the sky. It hangs above the world with a silence so vast that it seems almost alive. And beneath it, human beings stand in darkness with nothing but firelight behind them and stars before them. The land around them is dangerous, shifting, and often unknowable. Rivers flood without warning. Herds vanish over ridgelines. Cold seasons return with a cruelty that can empty a valley. Yet above all of this, night after night, certain lights return. Some appear in the same part of the heavens, some drift slowly. The moon changes its face, and then becomes whole again. The sun rises farther north, then farther south, then turns back as if obeying an invisible boundary. In a world where so much is uncertain, the sky offers pattern, and pattern is power. This is where the story begins. Not with a telescope, not with a written calendar, and not with a priest in a temple, but with people watching. A hunter at the edge of a frozen plain notices that a bright cluster of stars appears before the bitterest part of the year. A woman gathering shellfish along a tidal shore learns that the moon and water seem to answer one another. A group moving across grassland remembers that when certain stars rise before dawn, animals begin their seasonal path. None of this is science in the modern sense, but it is not superstition in the careless sense either. It is attention sharpened by survival. It is memory passed across generations. It is the first slow conversation between human beings and the heavens. Before we go deeper, take a moment to like the video and subscribe, if this is the kind of history and mystery you enjoy, because the ancient sky is not only a beautiful background to the past, in many places it becomes the hidden framework of civilization itself. To understand lost civilizations, it is tempting to look down first. Archaeologists dig into soil, sift through ash, trace the foundations of houses, and follow the stains left by wooden posts that vanished thousands of years ago. They study bones, seeds, pottery, tools, roads, canals, and collapsed walls. Yet again and again, the deeper story forces the eyes upward. A temple is not placed randomly. A passage grave may open toward the sunrise on one special morning. A city may be arranged around directions that are not merely practical but cosmic. A ruler may claim authority not simply because he commands soldiers, but because he is believed to stand between earth and sky. The heavens become a map of order, and the society beneath them tries to live inside that map. What survives in the record suggests that ancient sky knowledge had many forms. Some of it was practical, as plain and necessary as knowing when to sow barley or when to expect the floodwaters. Some of it was navigational, guiding sailors across waters where no landmark could be seen for days. Some of it was political, allowing priests, scribes, and rulers to predict eclipses, mark festivals, and present themselves as guardians of cosmic balance. Some of it was spiritual, transforming stars into ancestors, gods, animals, roads, fires, or souls. Scholars still debate how much of this knowledge was exact observation and how much was symbolic pattern-making, because the evidence remains incomplete. A line of stones may point toward a solstice sunrise by design, or by chance, or because later people gave meaning to an older structure. A myth about a star may preserve careful astronomy, or it may preserve a story whose astronomical meaning has been exaggerated by modern readers. The past does not hand over its secrets cleanly. Still, there is no serious doubt that ancient peoples watched the sky with patience and sophistication. The modern world often underestimates what can be known without metal instruments, printed tables, or glass lenses. A person who sees the same horizon every morning for 40 years can notice things that a hurried visitor misses. A community that gathers observations for centuries can create a living archive without writing a single word. Stones, stories, rituals, and routes can become memory devices. The hill where the winter sun returns is remembered. The notch where the moon stands low is remembered. The star that appears when the dry wind begins is remembered. In this way, the heavens enter the body of culture. But sky knowledge is never only about beauty, it carries risk. To predict is to claim power over uncertainty, and uncertainty is stubborn. If a priest says the rains will come and the rains fail, the sky becomes a dangerous witness. If an eclipse appears at a moment of war or famine, people may interpret it as warning, accusation, or proof that the world has fallen out of balance. If a city is built around an idea of cosmic order, then drought, invasion, or collapse can feel not merely political, but universal. No single explanation fully accounts for the fall of ancient societies, yet many of them lived inside a world where the movements above and the fortunes below were believed to be deeply connected. This connection leaves strange traces. At places older than writing, stones stand with a patience that outlasts every voice that raised them. In Egypt, pyramids and temples speak in geometry, light, and direction. In Mesopotamia, clay tablets preserve nights of watching, where scribes record the wandering of planets and the sudden appearance of comets. In Mesoamerica, the movements of Venus become entangled with war, kingship, and ritual time. Across the Pacific, navigators memorize stars not as distant objects, but as roads across an oceanic world. In China, court astronomers observe the heavens because an emperor's right to rule is thought to depend on harmony between heaven and earth. In Greece, inherited observations begin to turn into models of an unseen order, as thinkers try to measure not just when celestial bodies move, but why. And yet the deeper one looks, the more humbling the subject becomes. Ancient sky knowledge guided civilizations, but it did not save them from disappearance. Cities aligned to the sun could still be abandoned. Calendars of great elegance could still fail to prevent hunger. Priests who read Venus could not always read political unrest. Mariners who crossed immense seas could still lose islands to drought, conflict, or ecological strain. The sky gave order, but it did not remove fragility. It offered rhythm, but not immunity. That may be why its traces feel so haunting. A broken observatory, a buried temple axis, a carved lunar count on bone or stone. A myth that remembers a star no longer named in the same way. All of these suggest minds reaching across time toward pattern. They remind us that lost civilizations were not lost because they were simple. Many were intensely observant, patient, and intellectually alive. Their knowledge was different from ours, woven into ritual, authority, landscape, and memory. But it was knowledge all the same. Under the same sky we see now, they built calendars, planned journeys, blessed kings, feared omens, planted fields, and tried to understand their place in the turning dark. The story of ancient sky knowledge is therefore not just a story about stars. It is a story about how human beings learned to survive by noticing repetition, how they turned observation into meaning, and how meaning became architecture, politics, religion, navigation, and sometimes the last visible signature of vanished worlds. Long after the voices are gone, the alignments remain. Long after the cities collapse, The sun still rises through the ruined doorway. And in that quiet meeting of light and stone, the ancient question continues. The first sky watchers do not leave behind observatories in the way later civilizations do. They do not carve royal names beside eclipse records, or build libraries where generations of scribes can compare one year with another. Their records are quieter, scattered, and often difficult to read. A notch cut into bone, a repeated mark on stone, a burial arranged toward a horizon, a seasonal campsite placed where animals and light return together. These are fragile clues, and scholars still debate exactly how much they reveal. Yet the larger pattern is hard to ignore. Long before cities, long before writing, human beings are already living inside cycles. The sky is not decoration above their world. It is part of the world's working machinery. For mobile hunters and gatherers, time is not measured in numbered months. It is felt in cold, hunger, fattening animals, ripening fruit, flowering plants, fish runs, bird migrations, and the changing sound of wind across grass or ice. But these earthly signs are not always enough. Weather can mislead. A warm spell may arrive before winter's truly ended. A herd may appear early in one valley and late in another. The sky offers something broader, something less easily fooled by the mood of a single week. The moon swells and disappears with a rhythm visible to everyone. Certain stars return to the pre-dawn sky near the same part of the year. The sun's rising point creeps along the horizon, reaches a limit, then turns back. For people who depend on movement, memory, and timing, these repetitions become a kind of invisible path. One of the most surprising things about early sky watching is that it may not begin with abstract curiosity, but with food. A band following reindeer, wild horses, gazelle, or bison does not need a written calendar, but it does need seasonal judgment. Arrive too late at a river crossing, and the animals have passed. Gather eggs after the nesting season, and there is nothing to gather. Reach a plant-rich valley before thaw, and the land is still locked in that world. Noticing that a bright star appears before a migration, or that a full moon helps night travel during a particular season, is not mystical in the beginning. It is practical. Only later, perhaps, does the practical become sacred, because anything that helps a group survive long enough begins to gather meaning. The moon is probably among the earliest celestial bodies to be watched closely, because it changes in a way that feels intimate and dramatic. It grows from a thin arc to a full disk, fades again, vanishes, and returns. Its cycle is short enough to be remembered by ordinary people, yet long enough to organize waiting. It also alters the night itself. Under a full moon, landscapes open, paths, water, animals, and human faces become visible. Under a dark moon, danger thickens and the stars sharpen. For coastal people, lunar rhythms may become tied to tides, shellfish gathering, fishing, and travel across exposed flats. The evidence remains incomplete, especially for the deepest past. But ethnographic comparisons and archaeological patterns suggest that many societies learned to connect moonlight, water, animal behavior, and ritual long before they had formal astronomy. Some ancient marks have been interpreted as lunar counts, though caution is necessary. The famous carved bones and antlers from Ice Age Europe, with rows of incisions and repeated patterns, have sometimes been described as calendars. Some may indeed record phases of the moon or cycles of days. Others may count kills, rituals, exchanges, or something no longer recoverable. No single explanation fully accounts for them, but their very existence shows that Upper Paleolithic people were capable of symbolic recording, repeated observation, and numerical thinking. These were not minds trapped in the immediate moment. They were minds able to track absence, return, and expectation. That is the mental foundation from which later calendars grow. As the last ice age loosens its hold and climates shift, sky watching becomes even more deeply tied to place. Groups return to favoured campsites, river valleys, lake edges, and hunting grounds. Horizons become familiar. A mountain notch, a lone tree, a cliff edge, or a distant ridge can serve as a marker without being built by human hands. When the sun rises near that notch at the coldest turning of the year, people remember. When it sets behind a certain ridge before summer abundance, they remember again. The horizon becomes a measuring instrument, vast and patient, requiring no metal, no lens, no written table, only repeated attention across years. Then comes one of the great transformations in human history: farming. It does not happen everywhere at once, and it does not happen for one simple reason: climate, population, local plants, animal behaviour, experimentation, and chance all play their parts. But wherever cultivation begins to matter, timing becomes more demanding. Seeds placed too early can rot in cold ground. Seeds placed too late may fail before dry heat. Harvest must be gathered before loss. Stored food must last through lean seasons. The sky, already watched by hunters and gatherers, now becomes even more closely linked to planning, labour, and social coordination. Early farmers do not simply look up and decide when to plant by the stars alone. They read soil, temperature, rain, river levels, insects, and inherited experience. But celestial cycles help create a larger framework. The solstices and equinoxes, even if not understood in modern astronomical terms, mark turning points in light. The lengthening day promises warmth. The shortening day warns of cold. The heliacal rising of a star, the first brief appearance before sunrise after a period of invisibility, can become a seasonal signal with enormous cultural weight. Later, Egypt will famously connect the rising of Sirius with the Nile flood, though the relationship is more complex than a simple alarm bell in the sky. The deeper point is that stars can become seasonal anchors, tying heaven to earth through repeated experience. With farming also comes gathering at fixed places. Villages grow, ritual spaces become more permanent, people bury ancestors near homes, fields, or monuments. The sky is no longer only something that guides movement through a landscape. It begins to organize the landscape itself. A place where the sun returns may become a place where people gather. A seasonal ceremony may reinforce planting, marriage, exchange, memory, and authority all at once. What survives in the record suggests that practical timing and sacred meaning were rarely separate. A community does not have to choose between using the sky for agriculture and honouring it in ritual. In ancient life, the useful and the sacred often occupy the same ground. This is why the earlier sky knowledge is so difficult to classify. It is not astronomy as a modern scientist would define it, yet it is not merely myth. It is observation carried in story, survival carried in ceremony, and memory fixed to horizon and light. It belongs to people who know the world by walking through it, watching it, and returning to the same signs again and again. Their civilizations, if we can even use that word yet, are still small compared with the empires to come. But the habit that will later guide temples, calendars, kings, voyages, and vanish cities is already forming. Someone watches the moon disappear and return. Someone notices the sun pause at the edge of its path. Someone remembers a star before the season changes. And with that remembering, the sky begins to become history. As settled life deepens, the sky begins to leave heavier marks on the earth. The horizon that once served as a memory line for hunters and gatherers becomes something people reshape with their own hands. They raise posts, drag stones, cut ditches, mound earth, and open passages toward chosen points of light. A great stone does not move itself, and a ditch does not appear because one person has an idle afternoon. These monuments require labour, coordination, food, memory. and a shared reason powerful enough to bring people back again and again. The reason is not always visible now, but one clue keeps returning stone, and Earth seemed to be listening to the sky. Across Western Europe, from Ireland and Britain to Brittany and beyond, the late Neolithic world fills with monuments. Some are circles, some are long barrows, some are passage tombs hidden under mounds of earth and stone, some are avenues, banks, timber rings, and lonely standing stones that look accidental until the landscape is studied. They are not all observatories. That simple label can mislead. These places are also burial grounds, gathering places, territorial statements, ancestral monuments, ritual theatres, and works of social memory. Scholars still debate the balance between these meanings, yet it is misleading to ignore the sky, because some alignments are too carefully framed to be dismissed as chance. One of the most famous examples stands in the Boyne Valley of Ireland, where the great mound of Newgrange was built more than 5,000 years ago. From outside, it appears as a rounded hill edged with stones, but inside, a narrow passage leads into a chamber deep within the mound, around the winter solstice, when the year reaches its darkest turning. The rising sun can send a blade of light through a special opening above the entrance and into the passage. For a short time, the interior glows. The effect is brief and weather-dependent, but not random. The builders shaped stone, passage, roof, and horizon so that the darkest days of the year could be answered by returning light. What survives in the record suggests a society concerned with ancestry, death, renewal, and time. The ceremony is lost, but the architecture performs. Stonehenge carries a different weight, partly because it has been asked to bear too many modern fantasies. It has been called a temple of the sun, a lunar computer, a healing centre, a cemetery, a calendar, and much else. Some ideas are supported in part, others stretch the evidence too far. What can be said with confidence remains remarkable. The monument was built and rebuilt over many centuries. Its main axis aligns with the midsummer sunrise in one direction and the midwinter sunset in the other. Nearby cremation burials, timber structures, feasting debris, and the wider ceremonial landscape show that Stonehenge was not isolated. It belonged to a ritual world where the movements of the sun, the presence of the dead, and gatherings of the living were likely intertwined. Its massive sarsens came from relatively nearby sources, while smaller bluestones were brought from West Wales. A journey still astonishing even when one avoids exaggeration. The evidence remains incomplete, but the stones may have carried ancestral, regional, or sacred significance before they ever reached Salisbury Plain. Farther north, in Scotland, recumbent stone circles introduce another layer of celestial attention. These circles often include a large stone laid horizontally between two upright flankers, usually positioned in the southwest part of the ring. Some researchers argue that these settings relate to the moon, especially the dramatic swings of moonrise and moonset over long cycles. The moon does not behave as simply as the sun. Its path shifts through an 18.5-year cycle, creating events known as major and minor lunar standstills. Whether Neolithic and Bronze Age communities tracked these cycles systematically remains debated, but the possibility reminds us that ancient sky-watching could be patient on a scale modern people rarely practice. A society without writing might still preserve observations over generations if they were embedded in ritual gatherings and repeated performances. Beyond Europe, early monumental sky knowledge appears in other forms. In the Egyptian desert at Nabta Playa, stone arrangements and megalithic remains have been linked by some researchers to summer solstice alignments and seasonal movement during a wetter phase of the Sahara. The site is not a miniature Stonehenge, despite popular claims that make it sound too neat, but it does show that pastoral peoples in what is now desert were creating ritual landscapes long before the pyramids. In many regions, people are not simply living under the sky, they are building with it. Still, Ancient alignments are dangerous evidence. A circle has many possible sight lines. A stone can point in more than one direction. A ruined wall may seem meaningful only because modern observers search for meaning. If enough monuments and horizon points are tested, some impressive matches will appear by chance. This is why careful archaeology matters. The strongest cases combine alignment with context-repeated patterns across related sites, construction choices, visible horizon features, burials or offerings, and cultural signs that celestial cycles mattered. The weakest cases begin with a dramatic claim and then force every stone to obey it. The people who built these monuments did not necessarily separate astronomy from ceremony, engineering from memory, or measurement from myth. The modern categories would have seemed strange to them. To align a passage with the winter sun may have been at once a technical act, a sacred act, a political act, and an ancestral act. It may have gathered scattered communities, confirmed shared stories, marked obligations, and made the return of light feel like something held in common. When the sun entered a chamber or set along an avenue, the event was experienced by bodies standing in cold air, by families remembering the dead, by leaders organizing labor, by children learning that the world had a rhythm older than anyone alive. This is the deeper importance of stone circles and solar lines. They show that sky knowledge had begun to harden into place. The heavens were still moving, distant and unreachable, but human beings were learning to catch their cycles in architecture. They made the horizon into a calendar, the mound into a chamber of light, the circle into a gathering of earth and sky. Many meanings are gone, and some modern interpretations remain uncertain. Yet at dawn on the right day, when sunlight touches stone exactly where ancient hands intended, the distance between the lost builders and the present narrows. For a moment, their knowledge is not buried. It happens again. Once people begin to live beside fields, the sky becomes more than a distant pattern. It becomes part of the food supply. A community that plants grain cannot afford to treat time as a vague feeling, because the earth rewards patience but punishes mistakes. Seeds must meet the right soil, the right moisture, the right warmth, and the right season. Harvest must be cut before storms flatten it or birds and insects claim it. Stored food must be counted against the length of winter or drought. In this new world of fields, granaries, animals, and permanent villages, the heavens become a vast clock hung above human hunger. This does not mean early farmers simply looked at stars and ignored the ground beneath their feet. The best farmer watches everything: the smell of soil after rain, the swelling of buds, the behavior of insects, the fatness of grazing animals, the height of rivers, the direction of wind, the color of clouds. But the sky offers a larger order that local weather cannot always provide. A warm week may lie, a storm may arrive out of season, a river may rise late, the length of daylight, the turning of the sun along the horizon, and the return of certain stars create a broader rhythm. They do not remove uncertainty, but they give it a frame. In the early agricultural villages of the Near East, Anatolia, the Nile Valley, the Indus region, China, Mesoamerica, and other centers of cultivation, people learn that survival depends not just on labor, but on timing labor together. Planting, harvesting, repairing canals, moving herds, storing grain, and gathering for ritual all require coordination. A calendar, even a rough one, is therefore not a luxury. It is social technology. It tells people when to work, when to wait, when to gather, when to sacrifice, when to begin again. Before writing fixes calendars into formal systems, they live in memory, festivals, and repeated acts. A community may not say it is using astronomy, but when everyone comes together near a solstice, a first crescent moon, or the return of a seasonal star, the sky has already entered the machinery of society. One of the most important changes is that sky knowledge becomes communal authority. In a small mobile group, Many people may know the signs of season because everyone depends on them directly. In larger farming settlements, knowledge can become more specialized. Some people remember the old timings better than others. Some watch the horizon from sacred places. Some keep ritual sequences. Some know when the moon is right for a ceremony, or when a festival should be held before planting. Over generations, these roles can harden. The person who knows time becomes important. The person who announces the right day can shape labour, fear, hope, and obedience. This is one of the quiet roots of priestly power. It would be too simple to say priests invented calendars to control farmers. Reality is more complex, and scholars still debate how authority first developed in different regions. But what survives in the record suggests that ritual specialists often stood at the meeting point of sky, season, and social order. If the rains came after the ceremony gained weight. If the sun returned after the darkest days, the old rites seemed confirmed. If the river flood could be expected within a known part of the year, those who guarded that knowledge seemed to stand closer to the hidden rules of the world. The Nile gives one of history's most famous examples, though it must be handled carefully. Ancient Egypt depended on the annual flood, a life-giving rise that soaked fields and renewed soil. Later Egyptian tradition connected the heliacal rising of Sirius, the bright star the Egyptians associated with Sopdet, to the season of inundation. For many generations, this first appearance of Sirius before dawn came near the period when the Nile flood was expected. It was not a perfect mechanical signal, and local flood behaviour varied, but symbolically and calendrically it became powerful. A star vanished into the sun's glare, then returned. The river, too, returned. The land, baked and waiting, received water again. It is not hard to see how observation, agriculture, and sacred renewal braided together. Elsewhere, different skies mattered because different landscapes demanded different knowledge. In Mesopotamia, farmers depended on rivers that were less predictable and sometimes more destructive than the Nile. Irrigation required planning, maintenance, and collective effort. The sky helped structure months and festivals, but river management also demanded earthly administration. In early China, agricultural calendars became tied to seasonal nodes, ancestral rites, and imperial responsibility. In the Andes, farmers watched not only solstices and stars, but also mountain weather, frost, and water sources, because altitude can make a field succeed or fail within a short distance. In parts of the Pacific and the Americas, the appearance of certain star groups could mark fishing, planting, or travel seasons. The details differ, but the principle repeats: the sky is translated into local survival. A lesser-known and fascinating example comes from the way some traditional farming societies watched the Pleiades. This small star cluster, bright and easy to recognize, has been important in many cultures across the world. Its first rising or seasonal visibility has marked planting, harvest, sailing, or ceremonial cycles from the Mediterranean to the Pacific and the Americas. In some Andean traditions recorded much later, the clarity or dimness of the Pleiades before dawn was linked to expectations about rainfall and crop success. Modern researchers have explored whether this observation may relate to atmospheric conditions connected with El Niño patterns. Though the interpretation remains debated, the point is not that ancient farmers possessed modern climate science. The point is subtler. Long attention to the sky could preserve real environmental correlations, even when explained through a very different worldview. Yet calendars also create tension. Nature does not always obey the expected pattern. A star may rise on schedule while rains fail. A solstice may pass while frost lingers. A ritual may be performed perfectly, and still the crops may die. This is where sky knowledge meets its limit. It can organize expectation, but it cannot command weather. It can help societies prepare, but it cannot prevent every disaster. No single explanation fully accounts for ancient famine or collapse. Yet in many farming civilizations, environmental stress could damage not only the body of society, but its confidence in cosmic order. When the calendar says renewal should come, and renewal does not come, people do not experience that failure as data alone. They experience it as dread. Still, the power of the agricultural sky endures because most years the world does return. Dawn follows darkness, the moon renews itself, the sun turns back from its farthest point, birds migrate, seeds sprout, rivers rise, and fields ripen. The repetition is never perfect, but it is strong enough to build trust. Around that trust, villages become ritual landscapes, granaries become symbols of future time, festivals bind labour to memory. Ancestors are buried near the land their descendants cultivate. Children learn the year not as a page of numbers, but as a sequence of smells, lights, tasks, songs, and gatherings. By the time the first cities begin to rise, this older agricultural sky is already beneath them. The great urban astronomers of later Mesopotamia, Egypt, China, and Mesoamerica will refine observation into records, tables, and state rituals. But their work does not emerge from nothing. It grows from countless seasons in which unnamed farmers looked upward, then downward, then placed seed into earth with hope disciplined by memory. The heavens guided lost civilizations not because ancient people lived in fantasy, but because they lived in dependence. Above every field was a calendar of light. Beneath every calendar was hunger. Between them stood human beings, watching for the right moment to begin. Out of the older agricultural world rises a new kind of night. In the villages, the sky had helped farmers sense the turning year. But in the first cities of Mesopotamia, the heavens begin to enter written history. The land between the Tigris and Euphrates is never an easy place to trust. Its rivers can nourish fields, then tear through them. Its soils can produce abundance, then suffer from salinity and exhaustion. Its cities grow rich, crowded, competitive, and vulnerable. Here, beneath a sky often clear enough to expose the full architecture of the night, people begin to record celestial events not only in memory, stone, or ritual, but in clay. That change is enormous. A spoken observation can travel across generations, but it bends as it travels. A tablet, once dried or fired, can outlive the observer. It can be stored, copied, compared, and argued over. In Mesopotamia, writing first develops for very earthly reasons: accounts, grain, livestock, labour, offerings, ownership, administration. But the same scribal culture that counts barley and sheep eventually turns its attention upward. Stars, planets, eclipses, lunar phases, storms, and strange lights in the sky become part of a written archive. The heavens are still sacred, but they are also becoming data, though not data in the modern sense. They are signs to be read. The Mesopotamian city is a place where sky knowledge and power meet directly. At its centre rises the temple complex, and in some cities the stepped mass of the ziggurat lifts ritual space above the streets and courtyards below. The ziggurat is not an observatory in the simple modern picture of a priest standing on top every night with a neat chart in hand. That image is too tidy. These structures are religious, economic, and political centres, places where gods are honoured and resources are managed. Yet the connection between temple scholarship and celestial observation is real. The sky belongs to the gods, and the gods are thought to speak through signs. To read those signs is to stand close to danger and authority. The earliest Mesopotamian sky records are not astronomy separated from omen interpretation. They are woven into divination. If the moon is eclipsed in a certain month, if a planet appears in a certain position, if a halo surrounds the moon, if Mars shines ominously, the event may be read as a warning for the king, the city, the harvest, the enemy, or the land. Modern readers often rush to dismiss this as superstition, but that response misses something important. The omen system is also an attempt to organize repeated observation. It assumes that events are meaningful, that the universe has patterns, and that past signs may help interpret future danger. Its explanations are not scientific in the modern sense, but its habits of recording, comparing, and classifying become part of the long road toward predictive astronomy. One of the great collections associated with this tradition is known from later copies as Enuma Anu Enlil, a vast series of celestial omens. It links appearances of the moon, sun, planets, and weather phenomena to earthly consequences. The surviving copies come from later periods, and the tradition developed over time, so it should not be imagined as a single book written at one moment by one author. What survives in the record suggests a long scholarly culture, copying older material, expanding it, refining it, and preserving interpretations that may have roots centuries deep. The tablets are at once strange and disciplined. They reveal a world where a shadow on the moon could become a matter of state. The king is central to this system because Mesopotamian kingship carries cosmic responsibility. A ruler is not merely a military commander or tax collector. He is expected to maintain proper relations with the gods, protect temples, sponsor rituals, uphold justice, and defend the land. If the heavens show warning, the warning may be aimed at him. This makes celestial knowledge politically charged. A predicted eclipse is not just an event in the sky. It can become a crisis of legitimacy. In some periods, when an eclipse omen threatened the king, Mesopotamians used the extraordinary ritual of a substitute king. A temporary figure could be placed on the throne to absorb the danger indicated by the omen, while the real king was hidden or ritually protected. The details varied, and scholars still debate aspects of the practice, but the surviving evidence reveals a startling idea: the sky could be dangerous enough to reorganize power, even if only briefly. Over time, careful observation improves. Mesopotamian scholars distinguish planets from fixed stars because planets wander. Venus is especially important, bright and dramatic, appearing as morning star or evening star, vanishing, then returning. The so-called Venus tablet of Amisaduqa, preserved in later copies, records patterns of Venus visibility associated with the reign of a Babylonian king. Its exact historical use and chronological value remain debated, partly because copies are late and the data are difficult, but it shows the intensity with which celestial cycles were watched. Venus is not just beautiful. It is a moving sign, a clock, an omen, and eventually a predictable body. The Mesopotamians also developed star lists and schematic ways of organizing the sky. Texts such as Emul, Appian, known from first millennium copies, preserve information about stars, constellations, rising times, paths of the moon, and calendar relations. The tradition is already sophisticated by the time these tablets appear. It divides the heavens into ordered zones, links stars to months, and reflects long accumulated observation. This is not astronomy as later Greek geometry will imagine it. With models of spheres and arguments about cosmic structure, Mesopotamian astronomy is more arithmetical, observational, and procedural. It asks when something will appear, how cycles repeat, and what patterns can be extracted from long records. One lesser-known but crucial development is the use of mathematical schemes to predict lunar and planetary phenomena. By the late Babylonian period, scholars can forecast eclipses and planetary positions with impressive skill, using numerical methods. They do not need a physical theory of gravity, or even a geometric model of planetary orbits, to make useful predictions. They work from cycles, intervals, corrections, and accumulated records. This is one of history's great reminders that prediction and explanation are not the same thing. A civilization can predict the sky with great precision while explaining its meaning through gods, omens, and royal fate. Yet the Mesopotamian sky remains unstable in human terms. A predicted eclipse may show scholarly mastery, but it can also produce fear. A comet may be recorded as a sign of upheaval. A planet's unusual brightness may be tied to war or plague. No single explanation fully accounts for how people experience these events, because elite tablets preserve the concerns of courts and temples more clearly than the thoughts of ordinary farmers, boatmen, brewers, or labourers. Still, the sky touched everyone indirectly. Calendars shaped festivals, taxes, offerings, labour, and the timing of public life. The new moon mattered not only to priests but to the rhythm of the city. Mesopotamia's greatest contribution is not that it solved the heavens, but that it made the heavens recordable. Night after night, generation after generation, scholars created an archive of attention. They turned celestial movement into written sequence. They made the sky part of bureaucracy, religion, kingship, and mathematics. Their explanations were not ours, and their fears were not ours, but their discipline was real, in a land where cities rose, fought, flourished, and fell. Clay tablets held traces of moons, planets, eclipses, and omens long after the kings themselves were dust. The rivers shifted, walls crumbled, languages changed, but the habit of reading the night had entered civilization, and it would never entirely leave. In Egypt, the sky does not simply hang above the land, it seems to complete it. The Nile runs through a narrow green world bordered by desert, a line of life so precise that it can look almost drawn by a divine hand. On either side, the cliffs and sands stretch outward into heat, silence, and death. Above, the sun travels with overwhelming force, rising from the eastern horizon, crossing the white blaze of day, and sinking into the west where the dead are imagined to journey. Night follows, and the desert sky opens with a clarity that can make the stars appear close enough to guide the soul. In this landscape, order is not an abstract idea. It is survival, kingship, agriculture, burial, and eternity. The Egyptians called this order Mat, a principle that is difficult to translate fully because it means truth, balance, rightness, justice, and cosmic harmony all at once. The world must be kept in alignment, the river must return, the sun must rise, the king must perform his role, the dead must be transformed properly, temples must be oriented, rituals repeated, offerings maintained, names preserved. The heavens are not separate from this system. They are its most visible proof. Every sunrise demonstrates renewal. Every night journey of the sun suggests danger overcome. Every star that returns from invisibility hints at resurrection. What survives in the records suggests that Egyptian sky knowledge was never only technical, but it was never merely decorative either. It was woven into the deepest grammar of Egyptian civilization. The annual Nile flood gives Egyptian time its great rhythm. Unlike the harsher unpredictability of Mesopotamian rivers, the Nile's inundation was broadly seasonal, though still variable enough to bring anxiety. Too little flood meant poor fields. Too much flood could destroy homes and boundaries. The appearance of Sirius before sunrise, after its period hidden in the sun's glare, became closely associated with the coming inundation and the Egyptian New Year. This relationship was not a perfect natural alarm, and scholars still debate details of calendar drift, local observation, and regional timing, yet symbolically it was powerful beyond measure. A brilliant star vanishes, then returns in the dawn, the river rises, the fields are renewed, the land that seemed exhausted receives life again. Egyptian calendars developed from this need to organize sacred and agricultural time. A civil year of 365 days, divided into 12 months of 30 days plus 5 additional days, became one of Egypt's most influential achievements. It was not perfectly aligned with the solar year, so over long periods it drifted through the seasons, but its administrative usefulness was immense. Alongside it existed lunar and ritual reckonings, because ancient societies often lived with more than one kind of time at once. Bureaucrats needed schedules, priests needed festivals, farmers needed seasons, the dead needed eternity. No single calendar fully contained Egyptian time. because Egyptian time itself moved in cycles of labour, kingship, ritual, and cosmic return. The night sky was also divided and measured. Egyptian star clocks used groups of stars known as decans, which rose at particular intervals through the night and helped mark the passing hours. These were not clocks in the modern mechanical sense, but they show careful, repeated observation. In tombs and coffins, star tables could appear not merely as practical devices, but as part of the equipment of eternity. The dead person's afterlife was imagined within a cosmic order where night, stars, gods, and transformation mattered. To know the hours of darkness was not only useful for the living, it was meaningful for the journey beyond life. This connection becomes especially haunting in the pyramids of the Old Kingdom. The Great Pyramid at Giza, like other major Egyptian pyramids, is aligned with extraordinary precision to the cardinal directions. The method used remains debated, but many scholars think Egyptian builders may have observed circumpolar stars, shadows, or solar movements to establish true north. No single explanation fully accounts for every technical detail, but the achievement is undeniable. Without a compass, without modern surveying instruments, Egyptian builders fixed enormous monuments into the geography of the earth and the order of the sky. Stone became a cosmic statement. Inside some pyramids, narrow shafts have inspired long debate. In the Great Pyramid, certain shafts from the chambers have been linked by researchers to significant stars or regions of the sky, including Orion and circumpolar stars. Some interpretations are plausible in broad religious context, others become too precise and speculative when pushed beyond the evidence. What can be said more securely is that the king's afterlife was deeply celestial. Pyramid texts speak of the dead king joining the imperishable stars, ascending to the sky and taking his place among divine powers. The northern circumpolar stars, which never set from Egypt's latitude, had special symbolic force. They seemed deathless, always circling, never disappearing beneath the horizon. For a ruler seeking eternity, they offered an image no earthly throne could match. The sun, however, dominated Egyptian sacred imagination with unmatched brilliance. Solar religion grew in importance across Egyptian history, especially with the cult of Ra and later complex royal solar theology. The king was linked to the sun's daily renewal, and temples often framed light as an active force. At sunrise, the world was recreated. At sunset, the sun entered the dangerous hidden realm, where it must pass through darkness and enemies before returning again. This daily cycle gave cosmic shape to death and rebirth. A tomb in the west was not simply a burial place. It was positioned within a landscape of solar descent, memory, and transformation. Temple architecture often reflects this ordered vision. Egyptian temples are not randomly placed ceremonial buildings. Many are aligned to solar events, local horizons, sacred geography, or stellar phenomena. Though the exact intentions vary from site to site and must be studied carefully, at Abu Simbel, much later than the pyramids, sunlight famously penetrates the temple on specific dates and illuminates statues within the sanctuary, though the modern relocation of the temple has altered the setting slightly. The spectacle shows how Egyptian sacred architecture could turn light into ritual drama. The sun enters stone, and stone becomes alive with meaning. Yet Egypt's ordered cosmos was never free from uncertainty. The flood could fail, dynasties could weaken, foreign powers could enter, temples could lose wealth, tombs could be robbed. Even a civilization that built for eternity lived inside historical fragility. The sky offered order, but the earth still trembled with politics, hunger, ambition, and time. The Egyptians responded not by abandoning cosmic order, but by rebuilding it through ritual, inscription, architecture, and repetition. Their answer to impermanence was to carve permanence as deeply as possible. This is why Egyptian sky knowledge still feels so powerful. It guided fields and festivals, but it also shaped monuments meant to outlast ordinary human memory. It gave the king a path to the stars, the dead a language of renewal, the farmer a rhythm of flood and planting, and the priest a calendar of sacred acts. Where Mesopotamia read the sky as a dangerous text of omens, Egypt often imagined it as a vast system of return. The sun returns, Sirius returns, the Nile returns, the dead, if properly prepared, may also return into a transformed existence. Across the desert, stone points to north, tombs face west, temples catch dawn, and stars circle silently above. In that silence, Egypt builds one of the ancient world's most enduring visions, a civilization trying to make Earth resemble heaven, before both are swallowed by time. Beyond river valleys and desert temples, the sky takes on another role, one that belongs not to fields or monuments, but to the open sea, on land, a mountain, a river bend, a forest edge, or a familiar hill can steady the mind. At sea, the world removes those comforts. A canoe, raft, or ship may drift for days with no coast in sight, surrounded by water that repeats itself in every direction. Waves rise and fall, clouds erase the sun, winds shift. The horizon becomes a perfect circle. Beautiful and merciless. In such a place, the sky is not only sacred and not only seasonal, it becomes a road. Ancient navigation is often imagined as blind courage, as though early sailors simply pushed into the unknown and hoped the gods were in a generous mood. There was risk, certainly, and many voyages must have ended without return. But the evidence from seafaring cultures suggests something far more disciplined. Long before magnetic compasses became common, navigators learned to read the world as a layered system. Stars gave direction, the sun gave daily arc. Swells carried memory of distant winds. Clouds could gather over islands. Birds could reveal land beyond sight. Floating plants, watercolour, currents, and even the behaviour of fish could become signs. No single sign was enough. The skill lay in combining them, correcting one clue with another, and holding a root in memory when the sea tried to erase all marks. This kind of knowledge rarely survives in stone. It lives in bodies, songs, training, and practice. That makes it difficult for archaeologists to reconstruct, and scholars still debate how much can be inferred from later traditions. Yet the results of ancient navigation are visible on maps. Islands were reached, trade routes expanded, coastal worlds became connected, obsidian, shells, metals, spices, timber, pottery, and ideas moved across waters that would terrify an inexperienced traveller. The sea did not isolate ancient civilizations as completely as it appears to from land. In many places, it joined them. The Mediterranean is one of the great theatres of this sky-guided movement. Its coasts are broken by islands, peninsulas, and visible landmarks, so sailors could often move by coastal navigation. But even here, open water crossings mattered. Minoan Crete, Mycenaean Greece, Phoenician cities, Egyptian ports, Cypriot copper routes, and later Greek colonies all belong to a world where seamanship shapes history. Sailors watch familiar constellations, especially the northern stars. To hold direction at night, the Phoenicians, famous in Greek memory as master mariners, are associated with navigation by the stars, and later writers credit them with using the Little Bear, near the northern pole, as a guide. The details are filtered through later sources, but the broader point is sound star knowledge helped turn the sea into a network. In the Indian Ocean, monsoon winds add another layer. Here the sky is tied not only to stars but to seasonal atmosphere on a vast scale. Winds reverse direction during the year, allowing sailors to cross between Arabia, East Africa, India, and later Southeast Asia with timing rather than constant struggle. By learning when these winds arrive, merchants can ride one season outward and another season home. This knowledge becomes one of the foundations of ancient trade across the Indian Ocean. It carries pepper, ivory, textiles, beads, incense, and stories from shore to shore. The stars guide direction, but the winds decide opportunity. A sailor who misunderstands the season may be trapped for months or lost entirely. Yet the most astonishing achievement of ancient sky navigation lies in the Pacific. There, islands are scattered across distances so immense that ordinary land-based thinking begins to fail. The settlement of remote Oceania, including places such as Tonga, Samoa, Hawaii, Rapa Nui, and Aotearoa, New Zealand, required repeated voyages across open ocean. These were not accidental drifts alone. Some accidental movement surely occurred, and the evidence remains incomplete for individual journeys. But the scale and pattern of settlement point to deliberate exploration, return voyages, and navigational mastery. People carried plants, animals, tools, language, and social memory across blue distances that can still humble modern sailors. Traditional Polynesian navigation, preserved in later knowledge systems and revived in modern voyaging, reveals how such journeys could be possible without instruments. Navigators memorize a star compass, not as a drawn circle on paper, but as a mental structure of rising and setting points along the horizon. A star rises in one direction and sets in another. By steering toward or away from these points, a canoe can hold a course through the night, as stars climb too high or disappear. Others replace them. The navigator does not need to know the modern astronomy of stellar motion. He needs to know the sequence of the sky as it appears from a moving canoe. The method is not only stellar. Ocean swells may continue from distant weather systems even when local winds change, creating patterns that can be felt through the hull. Experienced navigators learn to sense these swells with extraordinary subtlety. Some accounts describe navigators lying down to feel the motion of the canoe, reading the sea through the body rather than the eye. Birds become living instruments. Certain seabirds feed at sea, but return to land at dusk, so their flight direction can reveal an island beyond the horizon. Clouds may form differently above land, reflecting lagoon colour or gathering over heated ground. Even the glow under clouds at night may hint at reefs or islands. To outsiders, this can sound almost supernatural. In practice, it is observation refined until it becomes instinct. A lesser-known detail is that some Pacific navigators conceptualized islands not simply as dots to be aimed at, but as parts of wider detection zones. An island creates signs around itself: bird ranges, cloud patterns, swell disruptions, drifting material, and changes in sea life. A voyage, therefore, does not require hitting a tiny speck in a featureless ocean with mathematical precision. It requires entering the island's world of signs and recognizing it. That does not reduce the achievement. It makes it more impressive because it shows a way of knowing the sea that is ecological, astronomical, and deeply human all at once. Still, even great navigational knowledge has limits. Storms can break canoes, clouds can hide stars for nights, currents can drag a vessel away from its intended path, memories can fail, political pressures, hunger, rivalry, or hope may push people into voyages more dangerous than their knowledge can fully control. No single explanation fully accounts for why every island was settled when it was, or why some voyages stopped while others continued. But the spread of people across the oceans proves that ancient sky knowledge was not confined to temples and calendars. It could be carried in the mind across water, where no monument could stand. In this way, sailors add a new dimension to the story. Farmers used the sky to return to seasons. Priests used it to order ritual and kingship. Mariners used it to cross emptiness. Their knowledge leaves fewer ruins, but it changes the human map of the planet. It guides trade, migration, colonization, exchange, and survival. Somewhere in the dark, a canoe moves under stars, its crew surrounded by water, its navigator holding a path that cannot be seen except in memory. Above them, The old lights rise and set, ahead, still invisible. An island waits inside its circle of birds, clouds, and waves. Across the oceanic world of star paths and swells, another kind of sky knowledge rises far inland, above forests, limestone plains, volcanic highlands, and cities built from white stone. In the Maya world, the heavens do not guide canoes across empty water so much as they guide time itself. They become a machinery of days, rituals, dynasties, war, planting, memory, and fear. The Maya do not inherit a simple sky. They build a sky of layered cycles, each turning inside another, until time feels less like a straight road than a vast set of interlocking wheels. The ancient Maya civilization develops across what is now southeastern Mexico, Guatemala, Belize, and parts of Honduras and El Salvador. Its history is long, varied, and never as simple as one rise and one fall. Cities flourish at different times, dynasties compete, trade routes shift, wetlands, forests, hills, caves, reservoirs, and causeways shape local power. The Classic period, roughly from the 3rd to the 9th centuries CE, leaves many of the most famous inscriptions and monuments. But Maya culture begins earlier and continues long after many great lowland cities are abandoned. This matters because the sky knowledge associated with the Maya is not the work of a single city or a single priesthood. It is a tradition carried, refined, adapted, and preserved across centuries. At the centre of this tradition is the calendar. The Maya use several ways of counting time, and their elegance still surprises modern readers. The 260-day sacred count, often called the Tzolkin in modern scholarship, combines numbers and day names in a repeating cycle. The 365-day solar year, often called the Harb, tracks a vague year of 18 20-day months, plus a short final period. Together. These two cycles create a calendar round of 52 Harb years before the same combination of sacred day and solar date repeats. Alongside them, the long count records vast spans of time from a mythic starting point, allowing historical events to be placed in a much larger cosmic framework. These systems are not simply calendars in the office sense. They are ways of placing human action inside sacred order. The Maya do not treat days as empty containers. Days carry qualities, dangers, associations, and ritual obligations. A birth date can matter. A throne accession date can be chosen or interpreted through calendrical meaning. A war may be timed within cycles that connect human violence to cosmic pattern. Inscriptions on stele and temple stairways do more than record that a ruler did something. They anchor the deed in time, and by anchoring it in time, they give it legitimacy. A king stands not only in a lineage of ancestors, but inside the measured turning of the cosmos. The sky strengthens that claim. Maya astronomers observe the sun, moon, planets, and especially Venus with extraordinary care. Venus is hard to ignore anywhere on Earth, but in Maya political and ritual life it seems to gain particular force. It shines brilliantly as morning star or evening star, disappears into the glare of the sun, and returns again. Its cycle of visibility can be tracked with enough regularity to become part of prediction. The Dresden Codex, one of the few surviving pre-Columbian Maya books, preserves Venus tables that reveal a sophisticated effort to follow this planet's movements across long periods. The surviving manuscript is post-classic, copied long after the classic cities reached their height, but it likely preserves older traditions. What survives in the record suggests accumulated observation, correction, and ritual use. Venus was not merely watched because it was beautiful. Its appearances could be dangerous. In Mesoamerican traditions, the heliacal rising of Venus as morning star often carried associations with warfare, sacrifice, and harm. Scholars still debate the exact meaning of Venus events in different Maya contexts, and no single explanation fully accounts for every inscription or codex table. Yet the broad connection between Venus cycles and moments of ritual or political significance is strong. A ruler who could act at the proper time appeared to be moving with the sky, not against it. Prediction became performance. Astronomy became authority. Eclipses also enter Maya sky knowledge. The Dresden Codex contains eclipse tables that seem designed to predict periods when solar or lunar eclipses might occur. These tables do not work like modern eclipse calculations, and they do not necessarily predict every specific eclipse visible from a given city with perfect certainty. Instead, they identify danger windows, intervals when the sky may darken and ritual attention is required. That distinction is important. The Maya did not need modern astrophysics for an eclipse to carry power. They needed a system that could anticipate celestial threat often enough to make ritual specialists appear deeply connected to cosmic order. Architectural alignments give the Maya sky a physical presence. Some buildings and complexes are oriented towards solstice or equinox sunrises and sunsets, zenith passages, or other horizon events. At Wasaktun, a group of structures has often been interpreted in relation to solar observations, though details and original function remain debated. At Chichen Itza, the famous pyramid known as El Castillo creates a serpent-like shadow effect around the equinox. Though scholars debate how intentional the effect was in its exact modern interpretation, across the Maya region, alignments vary by city, period, terrain, and purpose. The strongest evidence does not show one simple master plan, but rather a recurring concern with fitting buildings into meaningful directions of light, horizon, and time. One lesser-known but important celestial event in the tropics is the zenith passage of the sun. In the Maya region, the sun can pass directly overhead on certain days, casting almost no shadow at noon. This is unlike higher latitudes, where the sun never reaches the zenith. Such days may have been important for observation, ritual, and agricultural timing in parts of Mesoamerica. A vertical staff, a doorway, or the shaft of light in a building could reveal a moment when the sun stands at the top of the sky. The evidence remains incomplete for exactly how every community used this phenomenon, but it adds another dimension to Maya sky knowledge that outsiders from temperate regions often overlook. Yet the same calendrical and celestial systems that strengthen authority can also expose it. Maya rulers claim power through ancestry, warfare, ritual bloodletting, monument building, and the management of sacred time. If drought deepens, reservoirs fail, crops suffer, and warfare intensifies, cosmic order becomes harder to perform convincingly. The so-called classic Maya collapse is not a single sudden disappearance, and it does not affect every place in the same way. Many southern lowland cities decline or are abandoned between the 8th and 10th centuries, while Maya people and political centers continue elsewhere. Environmental stress, drought, warfare, shifting trade, political fragmentation, and social strain all likely contribute. But in a world where kingship is tied to cosmic maintenance, repeated crisis may have carried not only practical consequences, but ideological ones. When the rains fail, the ruler's ability to stand between earth and sky may begin to look dangerously fragile. The Maya sky, then, is not an isolated achievement of calculation. It is part of a civilization's living structure. It orders ceremonies, names days, times royal acts, warns of eclipses, watches Venus, frames buildings, and stretches human history into mythic depth. Its beauty lies in precision, but also in integration. Time is counted, carved, painted, performed, and feared. Even after many great cities fall silent beneath forest growth, the knowledge does not simply vanish. It survives in manuscripts, colonial-era records, inscriptions, oral traditions, and living Maya communities whose calendars and sky traditions continue in changed but meaningful forms. Above ruined temples, Venus still returns, the moon still darkens, the sun still reaches its high tropical throne, and the old cities, half covered by roots and rain, still seem to be waiting inside the cycles they once measured so carefully. Far to the east of the Maya forests and across the old river worlds of Asia, another civilization watches the heavens with a different kind of urgency. In ancient China, the sky is not only a field of gods, patterns, and seasonal signs, it is a mirror of the state. A strange light in the heavens may not remain a private wonder for poets or shepherds. It can become an imperial warning. A comet may suggest disorder. An eclipse may accuse the court of failure. A new star may be written down because heaven itself seems to have changed its face. In this world, to observe the sky is to guard the legitimacy of rule. Chinese civilization grows around rivers, farming, walled settlements, bronze power, ancestral rites, and dynastic memory. Over centuries, political authority becomes tied to the idea that heaven grants and withdraws the right to rule. This idea, later known as the mandate of heaven, does not mean a ruler is safe because he is divine in a simple sense. It means he must maintain order, ritual correctness, moral authority, and harmony between the human realm and the cosmic order above it. When floods, droughts, rebellions, earthquakes, or celestial disturbances occur, they can be interpreted as signs that something has gone wrong. The sky, therefore, becomes a political document, and the court needs specialists who can read it. This is where the Imperial Sky Bureau takes shape. Across different dynasties, official astronomers and astrologer astronomers observe, calculate, record, and report. Their duties change over time, and the institutions are not identical from one era to another, but the principle remains powerful. The heavens must be watched on behalf of the ruler. The work is both technical and dangerous. If an eclipse occurs unexpectedly, it can suggest failure. If a prediction is wrong, the error may carry consequences beyond embarrassment. Ancient accounts preserve stories of astronomers punished for failing to predict celestial events. Though some tales are difficult to separate from later moral instruction, still, the underlying tension is real. To serve the sky at court is to stand close to imperial anxiety. The Chinese record of celestial events becomes one of the most remarkable long-term archives in human history. Court observers note eclipses, comets, planetary movements, meteors, halos, unusual clouds, and what they call guest stars, temporary lights that appear where no ordinary star had been seen. These records are not modern astronomical logs, and scholars still debate the meaning or reliability of particular entries. Some are shaped by omen language, some are copied through later histories. Some descriptions are too brief to identify with certainty, yet taken together they preserve observations of enormous value. Modern astronomers have used ancient Chinese records to study comets, supernovae, and historical sky events that left traces still visible today. One famous example is the guest star of 1054 CE, recorded by Chinese observers during the Song dynasty. It appeared in the sky and remained visible for a long period, bright enough at first to be seen even in daylight according to historical accounts. Today, many scholars connect this event with the supernova that created the Crab Nebula. The observation comes much later than the earliest ancient dynasties, but it reveals the strength of the Chinese habit of recording transient celestial phenomena. When the sky changed, someone wrote it down. That single habit allowed a dying star to leave a double record, one in expanding gas across space, and one in ink within human history. Comets receive special attention. In many ancient cultures, comets are alarming because they do not behave like fixed stars or familiar planets. They appear suddenly, sometimes with long tails, then fade. They seem disorderly, and disorder in the heavens is rarely comforting. Chinese records describe comets with striking care, often noting their position, appearance, direction, and duration. Later silk manuscripts, such as the famous comet illustrations associated with the Mawangdui texts, show different comet forms with interpretive notes. These images reveal a mind trying to classify celestial irregularity, to turn frightening appearances into categories that can be remembered and interpreted. The explanations belong to an omen-based world, but the observational impulse is disciplined. Eclipses carry even sharper political force. A solar eclipse, in which daylight is visibly damaged, can feel like a wound in the order of heaven. Ritual responses may be required. Drums, ceremonies, and court acts can address the danger symbolically. But alongside ritual, prediction improves. Chinese astronomers develop calendrical systems and mathematical methods to anticipate lunar and solar cycles. Their work is not isolated from astrology, but neither is it careless. Calendar reform becomes a recurring concern across dynasties because the calendar is a tool of government. It fixes rituals, taxes, agriculture, official ceremonies, and imperial time. To issue a calendar is to declare control over the year. When a new dynasty rises, revising the calendar can be a way of announcing that heaven's order has been renewed under new rule. The Chinese sky is also divided into a celestial bureaucracy that mirrors the human one. Stars and constellations are grouped not in the same way as Greek constellations, but into a system of asterisms associated with palaces, officials, markets, walls, armies, and regions. The heavens become an imperial landscape. The pole star region, because it appears steady while other stars circle around it, gains special symbolic importance. It can represent the position of the ruler, still at the centre while the ordered world revolves. This does not mean every observer thought of the sky in exactly the same way, and the traditions develop across time, but the metaphor is revealing. China looks upward and sees not only animals and heroes, but administration, hierarchy, and courtly order. A lesser-known but important feature of Chinese astronomy is its attention to the changing positions of planets within this political sky. Planets are not merely wandering lights. They can represent phases, elements, directions, or warnings depending on context. Jupiter, with its roughly 12-year cycle, becomes especially important for calendrical and astrological systems. The movement of the planet is tied to divisions of the sky and cycles of time. Here again, observation and meaning are inseparable. The planet's motion is real, measurable, and repeatable, but its significance is interpreted through a cosmology in which heaven and state answer one another. This deep connection between sky and rule gives Chinese astronomy both strength and vulnerability. Its strength lies in continuity. Because courts need celestial records, observations are preserved across generations. Because calendar accuracy matters, mathematical astronomy advances. Because unusual phenomena are politically meaningful, they are less likely to be ignored. But the vulnerability lies in interpretation. A famine, revolt, or eclipse can become a judgment on the ruler. A court may respond with ritual repentance, policy changes, or attempts to control how signs are reported. The evidence remains incomplete for how ordinary people understood each celestial event, but at the imperial level, the sky is never neutral. And yet, despite its omen language, ancient Chinese sky watching contributes something deeply modern patience over centuries. A single observation can be mistaken. A single omen can be political theatre. But a civilization that records the heavens again and again builds a bridge across time. It preserves comets that will not return for generations, eclipses that can be recalculated, guest stars whose remnants still glow, and calendar reforms that show the struggle to bring human order into step with celestial motion. Like Mesopotamia, China reads the sky as a text. Unlike Egypt, it does not only seek eternal return, it watches for signs of dynastic responsibility, warning, and renewal. Above the palace roofs and city walls, the heavens move with majestic indifference. Below, scribes write quickly, because an empire may depend on what they have seen. Around the Aegean Sea, where islands break the water into glittering passages and mountains cut the horizon into sharp blue ridges, the sky begins to be studied in another way. It is still sacred, still useful, still tied to calendars, sailing, farming, festivals, and omens. But among Greek thinkers, a new habit gradually becomes visible. They begin to ask whether the heavens can be measured as a structure, not only watched, not only interpreted, not only feared, but explained through shape, number, proportion, and invisible order. This does not happen suddenly, and it does not happen in isolation. Greek astronomy grows from the older roots, especially from Babylonian records and Egyptian geometry, and scholars still debate how specific ideas travelled from one culture to another. Yet something distinctive develops in the Greek world, the attempt to turn the sky into a problem of reasoned models. The Greeks inherit a sky already thick with stories. Constellations carry mythic names. The gods move through weather, daylight, and night. Sailors use stars to cross the sea. Farmers watch seasonal signs, and poets place human fate beneath divine heavens. The oldest Greek sky is not a laboratory. It is a living ceiling of memory, navigation, agriculture, and sacred imagination. But the geography of the Greek world encourages contact, traders, soldiers, colonists, mercenaries, and scholars move between the Aegean, Egypt, Anatolia, Mesopotamia, and the Levant. Ideas travel with goods. A method learned in one port can be argued over in another. A calendar problem can become a philosophical question. Early Greek thinkers in Ionia, along the coast of western Anatolia, begin to speak about nature in terms that do not depend entirely on mythic personalities. They do not become modern scientists, and it would be misleading to make them sound too familiar, but they search for principles behind appearances. Thales, Anaximander, and others are remembered through later sources that are often fragmentary and sometimes legendary. So caution is necessary. Still, the tradition surrounding them suggests an intellectual shift. The heavens are not only a stage for divine action, they may also follow patterns that the human mind can grasp. An eclipse, for example, need not be only a terrifying omen, it may be predictable. The story that Thales predicted a solar eclipse in the 6th century BCE is famous. Though the evidence remains incomplete and the details are debated, later writers claim that an eclipse occurred during a battle between the Medes and Lydians, and that Thales had foretold it. Whether he personally predicted that specific event with confidence is uncertain. Babylonian astronomers had long tracked eclipse cycles, and any Greek knowledge of prediction likely depended on Near Eastern traditions. But the story matters because of what later generations thought it meant. A darkening sun could be pulled, at least partly, from the realm of pure terror into the realm of pattern. Greek astronomy is also transformed by geometry. To measure the sky, one must imagine distances and shapes that cannot be touched. The Earth's shadow on the moon during a lunar eclipse suggests a round Earth. The changing height of stars with latitude suggests that the observer's position on Earth matters. The movement of celestial bodies can be described through circles, angles, and spheres. The circle, perfect and unending, becomes especially powerful in Greek thought. This is not merely a mathematical preference. It is also a philosophical and aesthetic one. The heavens appear orderly, and Greek thinkers often assume that true celestial motion must be orderly in the most perfect way. The Pythagorean tradition adds the idea that number lies beneath reality. Much of early Pythagorean thought is difficult to reconstruct because it is wrapped in secrecy, later interpretation, and legend. But the association between number, harmony, and cosmic structure becomes deeply influential. The same ratios that produce musical intervals can suggest a universe ordered by proportion. The sky becomes not only a set of lights, but a kind of silent music. Modern science does not accept this in the old mystical form, yet the intuition that mathematical pattern underlies nature will have a long afterlife. By the 4th century BCE, Greek thinkers are creating increasingly elaborate models of celestial motion. Eudoxus of Cnidus develops a system of nested spheres to account for the movements of the sun, moon, planets, and stars. His model is not correct in the modern sense, and it does not explain the heavens as gravity and orbital mechanics do, but it is a remarkable attempt to reproduce complicated observed motions through geometry. The planets wander strangely, sometimes slowing, brightening, or moving backward against the stars in what is now called retrograde motion. To preserve the assumption of orderly circular motion while accounting for these irregular appearances becomes one of the great puzzles of ancient astronomy. Aristotle gives the cosmos a powerful philosophical architecture. The Earth rests at the centre, surrounded by celestial spheres. The heavens are made of a different, more perfect substance than the corruptible world below. Heavy things move downward, fire upward, and celestial bodies move in circles because circular motion is eternal and complete. This system is not simply an astronomical model, it is a world view, and its influence will last for centuries because it fits observation, philosophy, and common sense as ancient people experience it. The earth feels still, the sky appears to turn, the stars seem fixed on a great rotating sphere. A central earth is not foolish from the standpoint of naked eye observation. It is a reasonable model built from appearances, even if later evidence will overturn it. Yet Greek astronomy also contains bolder possibilities. Aristarchus of Samos proposes that the Earth moves around the Sun, a heliocentric idea many centuries before Copernicus. The evidence for his full reasoning survives only in fragments and reports, while one of his surviving works concerns the sizes and distances of the Sun and Moon within a geocentric-looking framework. Scholars still debate how widely his heliocentric idea was understood or accepted. It certainly does not become dominant. The central Earth remains far more convincing to most ancient thinkers. But Aristarchus shows that Greek astronomy is not intellectually frozen. Some minds are willing to move the Earth itself if the geometry seems to demand it. The Hellenistic period brings even more precise measurement. In Alexandria, where Greek, Egyptian, Near Eastern, and wider Mediterranean knowledge meet, scholars work in an environment shaped by libraries, royal patronage, and mathematical ambition. Eratosthenes estimates the circumference of the Earth by comparing the angle of the sun's rays at different locations, famously using observations associated with Syene and Alexandria. The exact details of his measurement and units are debated, but the achievement remains extraordinary. He understands that shadows in different places can reveal the size of the entire planet. The Earth becomes measurable not by walking around it, but by reasoning from sunlight. Hipparchus later advances astronomy through star cataloguing, trigonometric methods, and comparison with earlier observations. He's credited with discovering precession, the slow shift in the position of the equinoxes against the stars. This discovery requires not just one brilliant night of watching, but comparison across time. The sky, which seems eternal and unchanging to ordinary eyes, is shown to have a deeper motion. Even the fixed stars are not fixed in the simplest way. Here the Greek habit of geometry meets the older Babylonian habit of long records. The result is a more powerful astronomy than either style alone could have produced. The Greek sky does not replace older sky knowledge, it transforms it. Omens do not disappear. Astrology grows strongly in the Hellenistic world, especially as Babylonian celestial interpretation merges with Greek mathematical astronomy and Egyptian religious traditions. The same calculations that help predict planetary positions can also be used to cast horoscopes. This mixture may seem contradictory now, but in the ancient world prediction, meaning, fate, mathematics, and divine order often belong together. No single explanation fully accounts for how people balance skepticism, belief, observation, and philosophy. The heavens could be measured with astonishing care and still interpreted as signs of destiny. What Greece adds to the long human relationship with the sky is the courage to model the invisible. Farmers had watched seasons, priests had guarded calendars, navigators had followed star roads, and court astronomers had recorded omens. Greek thinkers ask what kind of hidden structure could make all these appearances possible. Their answers are often wrong, but their method changes history. They give later civilizations a language of spheres, angles, models, proofs, and cosmic scale. Beneath the same stars that guided sailors and warned kings, they imagine the universe as a rational order, and in doing so they make the sky not only a guide for lost civilizations, but a challenge to the human mind itself. The Greek habit of measuring the invisible gives the sky a language of geometry, but many civilizations leave their celestial knowledge in a more silent form. They leave it in ruined streets, temple doorways, buried plazas, walls that catch light on certain mornings, and cities whose original voices have fallen away. A written theory can be copied and argued over. A monument must endure weather, conquest, abandonment, and the patient violence of plants. When the language is lost, when the priesthood disappears, when the dynastic names no longer command fear, the stones may still point. That is one reason ancient sky knowledge feels so haunting in lost cities. It survives not as explanation, but as orientation. A ruined city is never only a ruin. It is a broken arrangement of choices. Someone decided where to place the main avenue, where to raise the temple, where the dead should lie, where the ruler should appear, where water should flow, where crowds should gather, and how the built world should face the horizon. Some of these decisions are practical. Builders follow ridges, rivers, defensible ground, winds, soils, and available stone. But in many ancient places, practical logic is joined by cosmic logic. The city is made to resemble an ordered universe. Directions matter, dawn matters, mountains matter. The movement of the sun or stars can turn architecture into a calendar, a stage, or a statement of power. Teotihuacan, in central Mexico, is one of the great examples of a city whose sky meanings remain powerful and uncertain, long before the Mexica later looked back on it with awe. Teotihuacan rose as a vast urban centre of pyramids, apartments, murals, workshops, plazas, and avenues. Its broad central route, often called the Avenue of the Dead, does not align exactly with the cardinal directions. Instead, the city grid is offset, and scholars have debated why. Some argue that the orientation relates to solar events on particular dates, others connect it to sacred mountains, landscape features, calendrical intervals, or older planning traditions. The evidence remains incomplete, partly because Teotihuacan's writing system, if it existed in a fully developed form, has not yielded the kind of historical texts found in Maya cities. The builders speak mostly through layout, paint, offerings, and stone. What survives suggests that the city's plan was not accidental. Its pyramids and compounds are set within a carefully controlled grid, one that organizes movement and sight. The pyramid of the sun, the pyramid of the moon, and the surrounding sacred landscape create a sense that urban space is tied to mountains, caves, water, fertility, and celestial order. Beneath the pyramid of the sun lies a cave, modified by human hands, which may have held deep ritual significance. Above rises a monument catching the light of the open sky. Earth below and heaven above are bound together in a city whose rulers remain strangely anonymous compared with kings elsewhere. Here, power may have been made less through portraits of individual monarchs and more through the arrangement of sacred space itself. Far to the north, in the dry lands of what is now the American Southwest, Chaco Canyon offers another kind of celestial cityscape. Between the 9th and 12th centuries, large buildings known as great houses rose in a harsh canyon environment. Roads stretched across the landscape with a precision that still surprises researchers. Pueblo Bonito, Chetroquetl, Casa Rinconada, and other structures were built with planning, labour, and ceremonial purpose that went far beyond ordinary habitation. Chaco was not simply a city in the familiar urban sense. It was a ritual, political, and regional centre connected to a wider world. Its buildings and markers show evidence of solar and lunar awareness, including alignments connected to solstices and possibly lunar standstill cycles. One of the most famous Chaconne features is the so-called Sun Dagger at Fajada Butte, where slabs of stone cast light and shadow across spiral carvings at significant solar times. The original arrangement has been affected by modern disturbance, and researchers must be careful when interpreting it. Still, the broader Chaco landscape contains enough repeated solar and lunar patterning to suggest sustained attention to the heavens. This does not mean every wall is a coded observatory. It means that ceremonial architecture, roads, horizon points, and celestial cycles belong to the same mental world. The people of Chaco built in a land where water was precious, seasons mattered intensely, and the sky offered both rhythm and authority. In the Andes, cities and sacred places often draw the heavens into a landscape already dominated by mountains. At Tiwanaku, near Lake Titicaca, monumental platforms, sunken courts, gateways, and carved stones speak of a powerful culture that flourished long before the Inca Empire. The site's astronomical meanings have been discussed for more than a century, especially in relation to solar alignments, but many older claims were exaggerated or built on uncertain reconstructions. Scholars still debate the exact functions and orientations of particular monuments, yet it is clear that Andean sacred geography frequently joins sky, mountain, water, ancestors, and political power. The sun's movement across peaks and plains was not a distant abstraction. It passed through a world of holy places. The later Inca make this relationship even more visible. Cusco, their imperial center, was organized through a network of sacred lines known as sikhs, radiating outward to shrines, springs, stones, hills, and ritual locations. Some alignments and ceremonies related to solar events, especially the June solstice, which mattered deeply in the highland ritual calendar at Machu Picchu. Structures such as the Intihuatana stone and the Temple of the Sun have been interpreted in relation to solar observation, although again, caution is needed with overly precise claims. What survives in the record suggests a civilization that treated landscape as a living sacred map, where the sky did not hover above the empire but entered its roads, shrines, agriculture, and royal ideology. Across the world in Southeast Asia, Angkor reveals another way a city can turn cosmic order into stone and water. The Khmer capital was not a single temple lost in jungle, but a vast urban landscape of reservoirs, canals, roads, shrines, houses, and sacred monuments. Angkor Wat, built in the 12th century, is famously oriented to the west, an unusual direction that has encouraged debate about its funerary, solar, and religious meanings. Its towers, galleries, and bas-reliefs express Hindu cosmology, especially the sacred mountain Meru, center of the universe. The temple is also tied to solar alignments visible at equinox from certain viewpoints. The exact intentions behind every alignment remain debated, but the larger vision is unmistakable architecture becomes cosmology. Stone mountains rise from engineered water, and the king's sacred world is built as a diagram of the universe. Lost cities remind us that sky knowledge often outlives the systems that once explained it. The people who processed through these plazas knew stories, songs, gestures, and ritual timings that are now gone. They may have watched a ruler appear when the sun struck a temple stair. They may have gathered when a shadow reached a carved sign. They may have understood a street not merely as a road, but as a path between earthly and celestial powers. Modern archaeology can recover part of this, but never all of it. No single explanation fully accounts for the emotional force these events once carried. And yet the ruins still perform. The sun still rises over Teotihuacan's old grid. Moonlight still falls across Chaco's canyon walls. Andean peaks still catch dawn above sacred stones. At Angkor, water still reflects towers shaped like a cosmic mountain, even when languages are broken, even when calendars are forgotten, Even when forests and deserts reclaim the avenues, the sky continues to move through the architecture. The old cities do not tell us everything, but they remind us that civilizations once built their sense of order into the meeting place of earth and heaven. When they vanished or transformed, that meeting place remained, waiting for light to return. For all the confidence that ancient sky knowledge could inspire, it carried a danger hidden inside its own power. To read the heavens was to claim that the world had order. To predict the return of the sun, the swelling of the moon, the rising of a star, or the danger period of an eclipse was to stand before a community and say that chaos could be measured. Most of the time, this claim was useful. It gave societies calendars, ceremonies, navigation, planting seasons, and political rhythm. But when the earth did not answer the sky, when rains failed after the proper rites, when famine deepened beneath an unchanged moon, when an eclipse came at the worst possible hour, the same knowledge that had supported authority could begin to turn against it. A calendar is powerful because it creates expectation. The river should rise, the wet season should begin, the king should renew the world, the fields should open, the festival should restore balance. In good years, each successful return strengthens trust. The people may not think of this as prediction in the modern scientific sense, but the emotional structure is similar. The world has promised repetition, and the guardians of time have promised to recognize it. Yet nature is not a servant of ritual. The sky moves with majestic regularity, while weather, disease, politics, and ecology are far more unstable. A solstice can be predicted with confidence. A drought cannot be dismissed by ceremony. This gap between celestial order and earthly disorder becomes one of the great pressures inside ancient civilization. Drought is especially cruel because it can make the sky seem both present and silent. The sun rises perfectly. The stars return. The moon completes its cycle. The calendar advances with all its familiar dignity, but the clouds do not gather, or they gather and pass without rain. Seeds fail in the ground. Reservoirs shrink. Animals weaken. Grain stores become guarded spaces. People who once gathered for festivals now gather for distribution, debt, migration, or revolt. No single explanation fully accounts for the decline of any major ancient society, but drought appears again and again as a force that exposes political and religious systems to stress. It does not need to destroy a civilization by itself. It only needs to press hard enough on food, trust, and authority until existing fractures widen. In the Maya lowlands, long periods of reduced rainfall appear to have played a role in the crises of the Classic period, though scholars still debate the timing, severity, and regional differences. The great cities did not vanish all at once, and Maya people certainly did not disappear, but in some places, dynastic monument building slowed, warfare intensified, populations shifted, and political centres lost power. If rulers had presented themselves as keepers of sacred order, then repeated drought would have been more than an agricultural emergency. It could become a public contradiction. The king performed blood rituals, raised stelae, honoured ancestors, timed ceremonies, and stood inside the calendar, yet the reservoir still fell. The evidence remains incomplete, and it would be too simple to say that people stopped believing because rain failed. Human societies rarely move so cleanly. Still, when sacred kingship depends on visible renewal, prolonged environmental failure is dangerous. A similar pressure may have existed in other forms in the ancient Near East. Mesopotamian rulers and priests watched the heavens for warnings, but celestial warning did not give them control over river behaviour, salinized fields, invasion, or internal unrest. If omens predicted danger, the court might respond with rituals, substitute kings, offerings, or political caution. Sometimes these responses may have helped by forcing attention toward crisis. Sometimes they may have offered only symbolic reassurance. What survives in the record suggests a world deeply concerned with averting divine anger. but clay tablets cannot tell us how many ordinary people felt when the warning passed and hardship remained. A farmer whose crop failed might respect the temple calendar and still curse the sky under his breath. Eclipses sharpened these tensions because they were sudden, visible, and frightening. A drought unfolds slowly, but an eclipse interrupts the order of day or night with dramatic force. The sun is wounded, the moon darkens, birds may quiet, people may shout, drum, pray, hide, or gather. In societies where rulers are linked to cosmic balance, such an event can feel like an accusation written in shadow. Prediction reduces terror, but it does not remove meaning. In fact, prediction can make the event more politically charged, because the specialists who know it is coming must decide how to present it. If they warn the court and the eclipse arrives, their authority grows. If they fail to warn, they seem negligent. If they warn and nothing visible happens from that region, the danger may look exaggerated. Knowledge becomes a delicate instrument. The Chinese imperial tradition shows this clearly. Court astronomers were expected to watch the heavens because celestial disorder could reflect on the emperor's mandate. An eclipse or comet could become a moral and political event, not merely an astronomical one. Officials might urge reform, ritual repentance, or caution. The sky offered a language through which political criticism could sometimes be expressed indirectly. A bad omen could say what a minister might fear to say plainly. The realm is out of balance. This did not mean every celestial event caused policy change, and interpretations varied across periods. But the structure mattered. When heaven showed disturbance, the throne could not entirely ignore it. There is a strange irony here. The better a civilization becomes at predicting the sky, the more exposed its interpreters may become. A priesthood that never predicts anything cannot be blamed for a failed prediction. But specialists who claim to know the timing of eclipses, festivals, Venus risings, or seasonal thresholds become responsible for accuracy. Their success raises expectations. Their mistakes are memorable. An even perfect astronomical prediction cannot guarantee earthly success. The sky can be calculated, society cannot. A calendar may be exact while the state collapses. This does not mean ancient people were naive. Many understood that rituals did not mechanically force nature to obey in a simple way. They lived with uncertainty more intimately than most modern people do. A farmer knew that signs could fail. A sailor knew that stars could disappear behind storms. A ruler knew that omens could be interpreted differently by rival factions. Ancient sky knowledge was not a childish belief that the heavens were easy to control. It was an attempt to live in a world where pattern and danger existed together. The trouble came when institutions built too much authority on the promise that cosmic order and human order were aligned. When predictions failed, the result was not always disbelief. Often it was reinterpretation. A failed rain ceremony might mean the ritual was performed incorrectly. The offering was insufficient. The ruler was impure. Enemies had angered the gods. Ancestors had been neglected. Or the signs had been misunderstood. Systems of meaning protect themselves by absorbing failure. But repeated crisis can exhaust even flexible explanations. Hunger is persuasive. So is defeat. So is watching a ruler claim harmony while the world around him breaks. The ancient sky guided civilizations, but it also judged them in the eyes of those who believed heaven and earth were connected. Its regularity could comfort, and its disruptions could terrify. Its patterns could strengthen kings, and its silence could weaken them. Above collapsing cities, the constellations did not collapse. Above dry fields, the moon still renewed itself. That may have been the most unsettling lesson of all. The heavens could appear perfectly ordered while human worlds failed below, leaving people to wonder whether they had misread the signs, angered the powers, or built too much certainty beneath a sky that promised rhythm but never promised mercy. The farther ancient sky knowledge travels into ruined stone, the the more tempting it becomes to see intention everywhere. A doorway faces dawn, a line of stones meets the moon, a pyramid casts a shadow, a road runs toward a mountain, and the modern mind, hungry for pattern, begins to connect every angle with a celestial event. Sometimes that hunger is justified. Ancient builders really did watch the sky. They really did align monuments to solstices, stars, lunar extremes, sacred mountains, and seasonal light. But sometimes the pattern belongs less to the builders than to the observer standing thousands of years later with a compass, a map, and a desire for mystery. This is one of the most difficult parts of the ancient sky story, separating the knowledge that guided lost civilizations from the meanings later ages have projected onto their ruins. The problem begins with abundance. The sky contains many possible targets. The sun rises and sets at different points through the year. The moon has its own complicated extremes. Bright stars appear and disappear seasonally. Planets wander. The horizon itself may include notches, peaks, ridges, valleys, and artificial markers. If a monument has several walls, doorways, corners, passages, stones, or sightlines, the number of possible alignments becomes enormous, given enough options. Some striking matches will happen by chance. A wall may point near a solstice sunrise not because ancient engineers intended it, but because builders followed the easiest ground, the shape of a ridge, the direction of an older path, or the practical needs of drainage and defense. Coincidence can look sacred when time has erased the ordinary reasons. This does not mean skepticism should flatten everything. Some alignments are strong because they are repeated, carefully framed, and culturally meaningful. Newgrange's winter solstice illumination is difficult to dismiss because the passage, roof box, mound, and light effect work together in a way that suggests design. Many Egyptian temples and pyramids show orientation choices that fit broader Egyptian concerns with cardinal directions, solar cycles, and celestial afterlife. Maya buildings and inscriptions often connect calendrical precision with political acts and celestial cycles, so solar or Venus-related orientations become more plausible when they appear in the right cultural context. In careful archaeology, the strongest interpretation does not rest on one impressive angle alone. It rests on architecture, landscape, artifacts, texts where available, repeated patterns, and knowledge of what that culture actually cared about. The weakest interpretations usually begin from the opposite direction. They start with a dramatic conclusion and then search backward for support. A monument is declared to encode a lost global science, or a city is said to mirror a constellation with impossible precision, or a temple is claimed to preserve knowledge of advanced astronomy far beyond what the evidence allows. These claims often ignore chronology, local culture, construction history, and the messy realities of ancient building. They can also underestimate ancient people in a strange way, by making their achievements depend on vanished super science, outside visitors, or hidden codes. Such theories take credit away from the patient observational skill that real ancient societies possessed. The truth is already impressive without needing to become impossible. One popular kind of claim links ancient monuments to star maps. Some cases deserve serious discussion, especially where a culture clearly associated certain stars with gods, ancestors, directions, or royal afterlife. But star map claims are especially risky because the night sky changes over long periods through precession, and because constellations are human groupings, not natural diagrams drawn with fixed meanings for all peoples. A modern observer may see Orion, the Pleiades, or the Milky Way in a pattern of temples. But ancient builders may have recognized entirely different figures or no figure at all. Scholars still debate some famous proposals, and the evidence remains incomplete. It is not enough for a layout to resemble a constellation after selective comparison. One must ask whether the culture named that pattern, valued it in the relevant period, oriented buildings accordingly elsewhere, and left supporting traces in art, text, ritual, or landscape. A lesser-known challenge is that many monuments were rebuilt, reused, and reinterpreted across centuries. A temple might begin with one orientation, then acquire new walls under a later ruler. A sacred place may remain important after the original reason for its placement is forgotten. A city may preserve an old grid long after its first planners are gone, forcing later buildings to follow inherited lines. This means that even when an alignment is real, its meaning may have changed. A solstice-facing passage built for ancestors might later become part of a different ritual story. A temple aligned with a local horizon event might be reinterpreted by later priests through a new theology. Ancient sky knowledge is not frozen at the moment of construction. It lives, shifts, and sometimes forgets itself. There is also the problem of landscape. Modern diagrams often show monuments floating in empty space, reduced to lines and angles. Ancient people experienced them with bodies. They walked roads, climbed terraces, waited in crowds, smelled smoke, heard chanting, felt cold dawn air, watched shadows move slowly across carved stone. A sunrise alignment might not have been meant for an abstract surveyor's line. It may have been a staged experience from a particular courtyard, platform, doorway, or processional path. In some cases, the emotional power of the event mattered more than exact mathematical precision. The sun did not need to strike a mark to the width of a knife blade for the community to recognize its return. A broad glow over a sacred mountain could be enough. This helps explain why symbolism and observation so often blend. A building may face east because the east is associated with birth, dawn, renewal, or divine appearance, without targeting one specific sunrise date. A tomb may face west because the west belongs to death and the setting sun, not because every burial was a technical solar instrument. A city may align with a mountain because that mountain is sacred, and the mountain itself may be sacred partly because of how light touches it at certain seasons. Practical, symbolic, and astronomical explanations need not cancel one another. In ancient worlds, they often reinforce one another. The task, then, is not to drain the mystery from the stones. It is to give the mystery a stronger foundation. The real wonder is not that every ruin secretly encodes advanced cosmic mathematics. The real wonder is that human beings without modern instruments watched carefully enough to build time into architecture, and that they did so while carrying meanings that were agricultural, political, ancestral, and sacred all at once. Some alignments are deliberate, some are accidental. Some are symbolic, some are later reinterpretations. Some remain unresolved because the people who could explain them are gone. And perhaps that is why the subject holds such power. A ruined doorway facing the horizon is both evidence and silence. It tells us that orientation mattered, but not always exactly why. It invites measurement, but resists certainty. It asks modern observers to be imaginative without becoming careless, skeptical without becoming blind. Ancient sky knowledge guided lost civilizations, but it did not leave behind a perfect manual. It left stone, shadow, fragments of text, repeated patterns, and unanswered light. To study these alignments well is to stand between two dangers, believing too much and seeing too little. The past waits somewhere between them, under the same turning sky. When civilizations fall, knowledge does not vanish in a single clean moment. It breaks unevenly. Some of it burns, some is buried, some is carried away by captives, merchants, priests, scribes, refugees, sailors, monks, and children who do not yet know they are preserving the remains of a world. A city may be abandoned, but its calendar can survive in villages. A temple may be destroyed, but a festival date may continue under a different name. A library may collapse, but one copied tablet, one translated book, or one remembered star path can pass into another tradition and begin again. Ancient sky knowledge is therefore not only a story of discovery, it is a story of survival through damage. The most obvious losses are physical. Clay tablets crack, Papyrus rots, bark books decay, wooden counting devices disappear, painted codices are burned, and inscriptions are worn down by rain, sand, or conquest. The sky itself remains, but the instructions for reading it are fragile. A stone alignment can outlast a city, yet the ritual that gave it meaning may vanish completely. A star name can survive in one language and disappear in another. A calendar can continue as a practical tool while its older sacred associations fade. This is why the history of ancient astronomy often feels like listening to a distant song through broken walls. The rhythm survives in places, the full melody does not. Mesopotamia shows one version of this broken survival. Its cities were conquered, rebuilt, abandoned, and absorbed across millennia, but its celestial scholarship proved remarkably durable. Babylonian records and numerical methods influenced Greek astronomy, especially during the Hellenistic period, when scholars had access to older Near Eastern observations. The zodiac itself, in the form later inherited by the Mediterranean world, owes much to Babylonian sky division and planetary tradition. Yet this transmission was not simple copying. Greek thinkers transformed what they received through geometry, philosophy, and new theoretical ambitions. Babylonian procedures that had once served omens, calendars, and prediction entered a wider conversation about cosmic structure. Knowledge survived by changing shape. Egypt offers another kind of transformation. Its temple calendars, decans, solar theology, and cosmic geography endured through dynastic shifts, foreign rule, and religious change, but not unchanged. Greek and Roman Egypt became a meeting ground where Egyptian priestly traditions, Greek mathematics, Babylonian astrology, and Mediterranean religious imagination mingled. Alexandria, in particular, became a place where older sky knowledge could be gathered, debated, and reshaped. The Library of Alexandria has become almost too symbolic in modern memory, sometimes exaggerated into a single lost treasure house whose destruction explains every gap in ancient knowledge. The truth is more complex. There were many losses, over time, through neglect, conflict, changing institutions, and the ordinary decay of manuscripts. No single fire destroyed the ancient mind, but the symbolic grief remains understandable, because written knowledge is always more vulnerable than the sky it describes. In Mesoamerica, the loss feels especially sharp because so few pre-Columbian books survive. Maya scribes once painted codices filled with calendars, rituals, astronomical tables, histories, and divinatory knowledge. After the Spanish conquest, many such books were destroyed as dangerous or idolatrous. Only a handful of Maya codices remain today, and among them the Dresden Codex preserves vital evidence of Venus tables, eclipse intervals, and ritual calendars. What survives in the record suggests that these manuscripts were only a small remnant of a much larger intellectual world. The destruction was not merely the loss of objects, it was the tearing of a long conversation between sky, time, kingship, and ceremony. Yet even there, knowledge did not die completely. Maya calendar traditions persisted in altered forms among living communities. Oral memory, ritual practice, colonial-era documents, inscriptions on stone, and later scholarship all preserve pieces of what once existed. The continuity is not simple, and it should not be romanticized as if nothing was broken. Much was broken, but neither should the story be told as total disappearance. Civilizations can lose cities and still leave descendants. They can lose books and still carry time and language, ceremony and landscape. A calendar remembered by people is not less real because an empire fell. In China, continuity took a different path. Dynasties rose and fell, capitals moved, libraries were damaged, and political upheavals reshaped institutions, but official record-keeping repeatedly returned. New dynasties had reasons to preserve, correct, and reinterpret the celestial records of earlier ones, because the sky remained tied to legitimacy and calendar authority. This created a powerful archive across centuries, comets, eclipses, guest stars, and planetary events passed from observation into dynastic histories. The political meaning of a celestial event might change, but the record itself could remain useful long after the omen was forgotten. Modern astronomy benefits from this continuity in ways ancient observers could never have imagined. The movement of sky knowledge through conquest is often morally complicated. Empires destroy, but they also collect. Conquerors may seize tablets, books, instruments, priests, and scholars. They may suppress one tradition while preserving parts of it for administration, astrology, navigation, or prestige. The Islamic Golden Age later becomes one of the great rebirths of ancient astronomy, translating and expanding Greek, Persian, Indian, and other traditions. Scholars in Baghdad, Damascus, Cairo, Cordoba, and other centres study Ptolemy, refine star catalogues, improve instruments, debate models, and preserve texts that might otherwise have been lost to Western Europe. This is later than many of the ancient civilizations already traced, but it belongs to the same chain of survival. Knowledge crosses languages because someone considers it worth carrying. Medieval monasteries, too, play their quiet part in Europe. Monks copy computers' tables to calculate the date of Easter, preserve Latin astronomical texts, observe calendars, and keep time for prayer. Their astronomy is not the same as Babylonian omen law or Maya Venus ritual, yet it shows the old pattern in another form. The sky organizes sacred time. Meanwhile, sailors continue to use stars. Islamic astronomers refine latitude measurement. Indian mathematical astronomy develops sophisticated planetary schemes, and Chinese observers continue their records. Ancient sky knowledge is no longer one thing. It has become a web of inherited methods, translated names, corrected tables, disputed theories, and practical habits. But rebirth always carries distortion. A copied manuscript may include errors, a translated star name may shift meaning, a foreign scholar may misunderstand a ritual context, a later empire may claim older knowledge as its own. Modern nationalism can also reach backward and turn ancient astronomy into a trophy, exaggerating the achievements of one culture while ignoring exchange with others. Scholars still debate many pathways of transmission, because the evidence remains incomplete. The honest story is rarely pure. Knowledge moves through contact, conflict, admiration, theft, curiosity, and need. What remains astonishing is that so much survived at all. A Babylonian observer notes a planet on clay, and centuries later Greek astronomers use inherited patterns. An Egyptian priestly calendar becomes part of wider Mediterranean timekeeping. A Maya codex, nearly alone after catastrophe, preserves tables that reveal generations of watching Venus. A Chinese court record of a guest star becomes evidence for a supernova. A Polynesian star compass, carried in oral tradition, helps modern voyagers prove again that the ocean could be crossed without instruments. The chain is damaged, but not severed. Ancient sky knowledge was broken many times, yet it kept returning because the need beneath it never disappeared. People still needed seasons, directions, rituals, legitimacy, and meaning. They still needed to know when to plant, when to sail, when to gather, when to fear, and when to begin again. Every collapse scattered knowledge, but every new society looked up and found the same moon, the same sun, the same wandering planets, the same patient stars. The sky allowed human memory to restart. Even when libraries fell silent and temples emptied, the heavens remained open, waiting for the next watchers to learn the old patterns in a new language. The ancient sky still guides us, though most of the time we no longer notice its hand. We wake to alarms instead of dawn, cross oceans by satellite, check seasons through screens, and let machines calculate the movements that once demanded generations of watching. City lights erase the older night from millions of eyes, The Milky Way, once one of the great rivers of human imagination, has become invisible to many people who live beneath it. Yet the structures built from ancient sky knowledge remain everywhere around us. They're hidden in calendars, clocks, maps, religious festivals, navigation systems, scientific language, and the simple fact that human time is still organised by bodies moving through the heavens. Every year still begins as an astronomical compromise. A day is the turning of Earth. A month remembers the moon, even when modern months no longer follow it closely. A year follows Earth's path around the sun. Weeks carry more complicated histories, shaped by planetary associations, religious practice, imperial administration, and cultural inheritance. Yet even they belong partly to the old human desire to divide time into repeating units. The calendar hanging on a wall or glowing inside a phone seems ordinary, almost boring, but it is a descendant of skywatching. Behind its neat boxes stand farmers waiting for floods, priests announcing festivals, scribes correcting lunar months, emperors issuing official time, and astronomers struggling to keep human records aligned with celestial motion. The same is true of navigation. A modern traveller may cross the Pacific without once looking at a star, but the system that guides the aircraft or ship still depends on a planetary understanding born from older questions. Latitude was once read from the height of stars. Direction was held by the pole star, by the sun's path, by wind, swell, and memory. Today, satellites carry atomic clocks and mathematical corrections so precise that they account for effects ancient thinkers could not have imagined. Yet the goal is familiar to know where one is beneath the sky. The tools have changed almost beyond recognition, but the human need remains the same. A Polynesian navigator feeling the ocean through the hull and a modern receiver calculating signals from orbit are separated by technology, not by the deeper impulse to find position in a vast world. Sacred architecture still preserves the old habit of orienting life toward cosmic order. Churches, mosques, temples, stupas, tombs, and ceremonial spaces often face directions with religious or astronomical meaning, though the reasons differ widely and must not be flattened into one explanation. Some face sunrise, some face holy cities, some frame mountains, rivers, or ancestral landscapes. Some inherit older alignments whose meanings have shifted over time. What survives in these orientations is the idea that direction matters, that a human building is not merely shelter but a statement about belonging. Ancient people expressed this through solstice light in stone chambers, pyramid alignments, temple axes, and city grids. Later cultures continue to do so in new languages of faith, empire, and memory. Science itself carries the legacy more directly. Modern astronomy is not ancient astronomy with better instruments. It is transformed by physics, telescopes, mathematics, spectroscopy, spacecraft, and theories that would have been unimaginable to early sky watchers. Yet it grows from the same patient discipline: observe, record, compare, predict, revise. Babylonian numerical astronomy, Greek geometry, Chinese records, Islamic star catalogues, Indian mathematical models, European telescopic discoveries, and global scientific collaboration all belong to a long chain of looking upward and refusing to forget what was seen. Scholars still debate many pathways of influence, and no single civilization owns the sky. Its study has always crossed borders, even when rulers tried to claim heaven for themselves. One of the more surprising legacies is that ancient records still help modern science. Observations of eclipses can refine understanding of Earth's changing rotation. Chinese records of guest stars help identify supernova remnants. Babylonian tablets preserve planetary and lunar data from nights more than 2,000 years gone. Medieval manuscripts record comets and unusual sky events. These records were often made for reasons modern science does not share: omens, calendars, dynastic legitimacy, religious timekeeping. But because someone wrote them down, they became useful in ways their authors could never have foreseen. a court astronomer fearing imperial judgment, a monk copying a table by candlelight, a scribe pressing signs into clay all become, unexpectedly, witnesses for the modern universe. Even the popular fascination with ancient alignments reveals a living inheritance. Though it needs care, people still travel to Stonehenge at solstice. They still gather at Newgrange, Chichen Itza, Abu Simbel, Machu Picchu, Angkor, and countless lesser-known places where light and architecture meet. Some come with careful respect. Some come with theories unsupported by evidence. Some come simply to feel wonder. The evidence remains incomplete at many sites. And not every dramatic alignment is ancient intention. Yet the longing behind these visits is real. Modern people, surrounded by artificial time, still want to experience a moment when the sun, the horizon, and human hands seem to agree. Lost civilizations were not guided by the sky because they lacked imagination or reason. They were guided by it because the sky was reliable enough to trust, mysterious enough to fear, and beautiful enough to turn into meaning. It helped them plant fields, cross seas, crown kings, bury the dead, predict danger, organize labor, and claim a place in the universe. It did not save them from drought, war, exhaustion, disease, conquest, or collapse. That is part of the lesson. Knowledge can guide a civilization without making it immortal. A calendar can be brilliant while the city that uses it falls silent. A temple can frame sunrise perfectly while its language disappears. The sky gives rhythm, not rescue. And still, the rhythm remains. The same Venus watched by Maya astronomers returns in the dawn. The same moon that troubled Mesopotamian kings darkens in eclipse. The same Sirius that shone before the Nile flood still burns in winter skies. The same polar stars that helped ancient builders find north still circle above stone and sand. Though slowly, almost imperceptibly, the heavens shift through deep time. We live after many collapses, but not after the sky. It is still there, above cities. Deserts, oceans, ruins, farms, and sleeping houses, carrying the old patterns forward. Ancient civilizations looked upward and found order. We look upward and find history. And so the story returns to the quiet place where it began, beneath a sky older than any wall, older than any throne, older than every calendar that tried to name its movements. The ancient watchers are gone now. Their fires have cooled into ash. Their cities have become mounds, ruins, fields, museum fragments, and half-buried stones warmed by the same sun they once measured with such care. The kings who claimed the favour of heaven no longer speak. The priests who guarded sacred days no longer lift their eyes from temple courts. The sailors who crossed black water by memory alone have vanished into ancestry, yet the sky they trusted, feared, and studied still turns above the earth with patient indifference. There is something humbling in that. Civilizations often imagine themselves as permanent while they are alive. They carve stone, raise towers, count years from the reigns of rulers, and build ceremonies around the belief that the world has been placed in order. But time is wider than any city. Rivers shift, forests return, sand enters doorways, languages fall silent. Even the most careful calendar can outlive the people who made it and become a puzzle for strangers. What remains is not certainty, but trace a shaft of sunlight in a dark chamber, a tablet marked with the path of Venus, a pyramid edge facing north, a forgotten road aligned with a horizon no one watches anymore. The ancient sky knowledge that guided lost civilizations was never a single secret. It was 1,000 acts of attention. It was someone noticing the moon before the tide, someone remembering a star before the rains, someone waiting in winter darkness for the sun to return through stone, someone at sea trusting a line of stars when there was no land in sight, someone in a palace recording a comet, not knowing that centuries later another kind of scholar would read the same record and see not an omen, but a visitor from deep space. Perhaps that is the gentlest lesson left behind. Human worlds are fragile, but attention endures in unexpected ways. A careful mark, a remembered direction, a story carried through generations, a building turned toward dawn. These small acts can cross distances their makers never imagined. The civilizations themselves may disappear, but their looking remains. And tonight, above the modern world, above lights, roads, towers, screens, and sleeping cities, the old heavens continue. The moon moves through its phases. Venus glows and vanishes and returns. The stars wheel slowly beyond the reach of memory. Somewhere, over a ruin or an ocean or a silent field, dawn is approaching the horizon, and for a moment, light and earth are about to meet again.